All right, AP Stat students, what we're going to do right now is we want to think about sample results that we get and say, is it plausible? Is it plausible that that could happen? So, for example, again, I want to go back to, I talk a lot about flipping of a coin in class. So I want to go back to if we'd flip a coin. Let's say we flipped a coin 100 times, which is a decent sample size there, like a decent number of trials. We flip a coin 100 times, and out of that time, we get a sample result, meaning this is what happens. 55 out of that 100 times we flip heads. We could say, is that plausible? Is that plausible to happen when we know it should be 50%? What we could do is we could find the probability of getting that sample result and asking if it's plausible based off of that, okay? And that's kind of the thinking that we're gonna do right now. Hey, we have a truth that we know, we have a given truth. We know 50% of the time, when we flip a coin, it should flip heads. But if we do it 100 times and we get 60 out of 100 times we flip heads, is that okay? So what we can do is we can find the probability of that happening and say, yeah, that was plausible to happen, or it wasn't plausible. For example, what's something that's not plausible? We know the given truth, 50% of the time we should flip heads. What if we flip a coin 100 times and 95 of those times we flipped heads? Is that plausible? Well, we could find the probability of that and establish that's not plausible. Something was wrong with that coin then, okay? And that's the conclusion that we would draw. That shouldn't have happened, but it did. We did it. We flipped that coin in 95 of those times. It was heads. We could find the probability of that result happening. It's gonna be very small, and since it's very small, but it did happen, we can go ahead and say, well, that truth is wrong. Something's wrong with that coin. Let's look at it in terms of this question here. Okay. What proportion of law students are male? To find out, a female student took an SRS of 100 students at her law school and recorded if they were male or not. Now, what we have up here is we have something called Fathom. That's a statistical software. A Fathom dot plot shows the results of taking 200 SRSs of 100 students from a population where the true proportion of male law students is 53%. So let me give you a little information here. Here's the story. We have a truth about a population of law students, just like we had a truth about flipping a coin and what proportion of the time should it be heads. The truth that we know right now is that 53% of all law students are male. Now, what we're going to do is we're going to take a simulation, okay, of 200 samples. So this computer generated 200 random samples of size 100. So each dot here, that represents 100 people being sampled. Now you can see this is on the actual, let's see, 51. Looks like it's on the 0.54, okay? What that means is 54% of these 100 people said that they were male in this dot alone. In this dot right here, this dot represents 100 people. 50% of that 100 people said they were male. Again, this dot right here, all of these dots represent a sample of 100 people. And where the dot is placed is what proportion of those 100 people were males. So you need to make sure that you understand that first. Now, we know there is assumed truth right now that 53% of law school students are males, just like there's an assumed truth that 50% of the time you flip a coin, you get heads. This student, though, is wondering, hey, when she did it, when she did it, she got something different. She said, suppose 60 students in the class sample that she sampled were male. Now this is getting at the question, is this plausible? Just like if we flipped a coin and we got 60 out of 100 60 of my 100 flips were heads. Is that plausible? And now what we're going to do to ask if this result is plausible, we're going to actually find the probability of it happening based off of a simulation, okay? Based off of a simulation. So does this give convincing evidence that more than 53% of students are male, meaning this truth is maybe wrong, okay? Just like I said, hey, when we flip a coin 100 times, and what if I get 95 times I flipped heads? Do we have convincing evidence that the truth, 50% of the time I flip heads, is not 50% anymore? So that's what we're getting at here. This is what the question is asking. There are 3 steps we need to do to answer this question, okay? And again, we're going to use simulation to answer that question. If I can just get this over. Step 1, you want to figure out what is that sample result. That sample result as a proportion, okay? So the number of successes divided by the total number sampled. What was our success in part A? Our success is we want to figure out if a student was male or not. So our sample result for this woman, she sampled an SRS of 100 people, okay? Right? Because how do I know that? It says that up here. She sampled 100 people. 60 of them were male, which gives us 0.60, okay? Step 2, now we want to figure out the probability of this happening so we can establish if this was a plausible result or not. We're going to find something called a p-value, okay? We're just going to call it probability right now, but by definition, that means we want to figure out the probability of getting this result or something more extreme than that, okay? So a probability of that result or something more extreme than that. So how do I do that? I first need to count up the number of dots that are your sample proportion that we just got and more extreme than that, okay? So your sample proportion or your sample result. So what I'm doing to figure out this step 2 is I'm using the simulation to figure out this probability, the probability of this happening, okay? So the number of dots that are 0.60 or more extreme than that. So let's go and count right now. 0.60 is right here. So I have 1, 2, 3, 4, 5, 6, or more extreme than that would be this way. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I have 22 dots that had a sample result of 0.60 or more than that, okay? So this is step 2. Oops. Now what I want to do is I want to divide that by the total number of dots. We don't need to count. I think we said 22 and I put 20, sorry. Give me a second, computer. Okay. We want to count the total number of dots, but in this case, we don't need to count the total number of dots because they tell us up here, there were 200 SRSs. So that means 200 dots up here. Okay, so 22 divided by 200. And that's going to give us 0.11, which is 11%, okay? So we have step 1, step 2. So now what we're saying is, hey, this sample result, based off of our simulation, the chances of it happening is 11%. So the chances of getting this or something more extreme than that is 11%. What does that mean now? What can we say about our truth? Again, just think about that coin again. 50% of the time we should flip heads. What if we had a sample of 100 flips and we had 95 of those we flipped heads? We can now figure out the probability of that happening, and we can say, hey, this coin might be off then, because that shouldn't have happened. That shouldn't have happened. 95 heads, if the chances of that happening are so small, we can go ahead and we can say, that shouldn't have happened. So how do we answer that question? How likely was the result? Well, what we want to do is we want to analyze and conclude. And here's how we're going to analyze. Our benchmark is 5%. I've talked to you guys about that before, but make sure you write down things. If you get a probability of a sample result happening that is less or greater than 5%, excuse me, so it's over 5%, the result, that sample result was likely. It could have happened, meaning we have no evidence that our claim or our current truth is wrong, okay? claim or current truth is wrong. So for example, if I flipped a coin 100 times and 60 of them were heads, and I figured out that 11% of the time that could happen, I have no evidence that my current truth is wrong, that that coin should not be 50%. Something's wrong with that coin. But let's say I flip a coin 100 times and 95 of them flip heads. Okay, 95 of them flip heads. And I figure out, now that was my sample result, 95 of the 100 times I flipped heads. And then I figure out the chances of that happening is only 2%. Well, now all of a sudden, that's unlikely. That result, 95 out of 100 times, should only have happened 2% of the time. That result I got is unlikely. As a result, I have evidence that my claim or my truth is wrong, meaning something's wrong with my coin. It was supposed to be 50%, but it's not, so something's wrong with it. Okay, so let's go back here. Based off the simulation, the chances of getting a sample result of 0.60 or more is 11%. Okay, this is kind of a fill in the blank problem. I would fill in here and here. We either have evidence or we have no evidence. That's, in this case, we have no evidence, right? Why? Because 11% is greater than 5%. That result is likely. So we have no evidence that the claim or the current truth, which was 53% of college, that's written wrong, sorry, 53% of the college being males is incorrect, sorry. We have no evidence that that is wrong. Her college is just like every other college in the population. All right, let's keep going. Again, stay with me. This is historically, this lesson in class has one that prompts a lot of questions. So please write down your questions. It's okay. And meet with me during office hours if you have more questions about it. Okay, part B. Let's say we're at a different college, the same girl, okay, or same similar situation with a girl questioning. She wants to know what proportion of students at her school are male. She knows that nationally the population says it's 53%, but she samples 100 people. And this time, not 65 like the other, not 60 like the other girl, but 65 students in the class were male. Does this give convincing evidence that more than 53% of students are male at her school? Okay, so step one, right? Step one, we want to take that sample result, proportion, figure out what that is. So the number of successes divided by the total sample. So hers number of successes, 65 of them were male. Divided by 100 people sampled. That's 0.65. Step two. The probability of that result being getting that result or something more extreme than that. So that's the number of dots that are your sample proportion, your sample result, and then more extreme than that, divided by the total number of dots. So let's go up there, 0.65. Well, look at that. What do you know? There's only one dot that is 0.65 with nothing else more extreme than that. Okay. One dot divided by 200. Well, that gives us 0.5. That's a half of a percent. Okay, step three, we're going to analyze. Was this result likely or was it not? And then we conclude based off of that analysis, okay? Was this likely or not? Well, the probability of this happening right here was 0.5%, which is less than 5%. That means that result is unlikely. It shouldn't have happened, but it did. And so now we have evidence that the claim is wrong. What is the claim? The claim is that the truth about the population of law school students is 53% of them are male. Now, we have evidence that that is wrong for this school. Based off the simulation, the chances of getting a sample result of 0.65 or more extreme than that is 0.5%. We have evidence that 53% of law students, we should say at this school, we have evidence that 53% of law students at this school are male is incorrect. All right, we are done with drawing conclusions based off of a simulation.